want to know. Okay, what do we want to know in this problem? The least amount of material, right? So we want to minimize the surface area. Good. So we put our heads together, we got it. Our goal is to minimize the surface area. Identifying what we want to know is huge because it lays the foundation for the whole rest of the problem. Okay? Now, knowing this, we can write the equation that we're actually going to find the minimum of. Okay? What is the equation that we're going to find the minimum of? Careful, we're going to use the derivative to find the minimum. What formula up here do we want to find the minimum value of? The area, the surface area. We want to find the least amount of aluminum, so we want to minimize, we want to find the minimum value of this guy right here. So the equation that we're going to work with is A equals 2 pi RH plus 2 pi R squared. That's the puppy we're working with. I want to find the lowest value of that, the minimum. Except I'm seeing a problem here. What's the problem? Too many variables. We got R and H. And R, pi is a constant. A we don't have to worry about here. This is bad. We're only in single variable calculus. Okay? If we were teaching multivariable calculus, which is third semester calculus, then we can do that problem. Okay? But we can't do it. So, the question is, how do I get rid of an R or an H? Sweet. Very good. Excellent. He says solve the volume for H. Watch this. This is really good. So here's a little side note. Okay. The volume has to be 355 milliliters. That's called a constraint or a restriction. The volume is also pi r squared. So I can say this, 355 equals pi r squared h. The volume is forced to be equal to 355. Okay? There's no way around this problem without having the fact that the volume is 355 milliliters. So we're forcing that. You see what this does for us now? We get to solve this for one of the variables, and then we can plug it into this guy up here. All right, what do you want to solve this for? What do you think would be good? I'd solve it for H too. So let's solve this for H. We're going to divide. So I've got H is equal to 355 over pi r squared. See that? Now, this is cool because now, being the coach, we're going to call substitution. And we've got A is equal to 2 pi r 355 over pi r squared, then plus 2 pi r squared. See that? And then I'm just going to finish this off. Therefore, area is equal to, actually I'm going to throw this over here because we're going to need this. So over here, that means therefore, area equals, what do you get from that? What do we get from that? What does this give you? Seven, 10. that give you?
Yes, yes.
710 over R. Everything else cancels out, right? Pi cancels. Remember, this is upstairs. 1's in the basement. And then we multiply. Okay. Plus 2 pi R squared. Put a big box around this, because this is what we want to find the minimum value. We want to find the minimum value of that equation. All right. How do we find the minimum value? Find the derivative. Find the derivative and then do what?
That's 0.
Yep. Find the derivative, set it equal to 0. So, here we go. Now, we're finding the derivative of A with respect to R. Okay, so I'm just going to write A prime, but we're finding dA dr. Okay, you need some help here. How do we find the derivative of 710 over R? We can use quotient rule, or we can use power rule. With R to what power? -1. So what do you give you? -710. Katie? Come on.
What?
Over what?
Over
Over R squared. Okay? That's using the power rule with R to the -1. Now, over here, 2 pi R squared, the derivative of that with respect to R is? 4 pi R, because we're taking 2 times 2, so that's 4 pi R to the first. That's our derivative. Okay, what do we do with the derivative? Set it equal to 0 to find our critical values. So 0 is equal to -710 over R squared plus 4 pi R. Again, this is following the technique of you telling me where you're going. Set this equal to 0. All right, how do I solve that equation? Fearful question to ask today. Just move the 4 pi over. How about we just do a trick? Sure. Tricks are good. Tricks are for kids. Tricks are for calculus kids. What's the trick on this one?
Get the R squared out of the bottom, multiply it by R squared.
Yeah. So the trick here is we're going to multiply both sides by R squared. By doing that, we simplify the equation. 0 is equal to -710 plus 4 pi R cubed. Now you get it. We can go ahead and solve this for R easily. So this would be 4 pi R cubed equals 710 divided by 4 pi. And R is the cubed root of 710 over 4 pi. Now, that's a nifty answer. That's the exact answer for what? At this point, what is this R value? What is it for us? What is it for us right now? All it is a critical value, okay? So this is a critical number. I want you to pull out your calculator. Let's crank out an estimate, an approximation for this.